Advanced Router Technology Part 6, Understanding IP Access Lists. Now, I don't know about you, but can you think of anything more fun than an entire nugget dedicated to nothing but IP access lists? Well, besides the Caribbean cruise. Me neither. I mean, access lists are one of the core features of Cisco routers that really branch into nearly every type of configuration that you can touch. And that's how I'd like to start this nugget off, is by getting into access lists. They're not just for access anymore. That's actually one of the minor things that they do is provide restrictions on IP packets going through your router. They actually apply to nearly every major feature that you can configure your Cisco router to support. So from there, we'll get into the foundations, the standard and extended access lists. And I know some of you may be versed in standard and extended lists, but I'd like to throw out kind of a laundry list of facts that you may or may not be aware of. And then I'd like to bring everybody up to the same page by going over the foundation configuration and what wildcard masks mean and that sort of thing. From there, we'll get into a lot of the new features that some of you may not be familiar with. Named access lists. And I say, why use anything else? I'm going to show you on a Cisco router just how powerful they've made named access lists in the recent versions of the iOS. They're as flexible as anyone would ever want. There's no more blowing away an entire access list and recreating it just because you can't reorder things and move them around. We'll get into that and talk why that's true. From there, we'll get into dynamic access lists. Cisco also calls this lock and key. This allows you to have a user authenticate to your router. And when they authenticate, they are allowed access from the device they authenticated from for X amount of time. And you get to define how long they have access and what they have access to. Now, that's often confused with time-based access lists. Time-based access lists don't require an authentication. They just are active on certain times of the day and night. Now, remember, think outside the box when we get into timed access lists. They're not just for access anymore. Sure, it might be great to provide web access during business hours or maybe after business hours, but think a little beyond that and think about applying an access list to maybe a demand dial circuit to say this circuit can only dial, maybe it's an ISDN link, it can only dial after business hours when the rates are a little bit lower. And we'll get into some other uses where time-based access lists can come into play. My first question is, why are they called access lists? Well, maybe because originally they were intended for access control, but not so anymore. Here's the official definition. An access list. It's a list of conditions executed sequentially from top to bottom. Now, anywhere in that definition, do you see something saying to provide access control? No, that's just one way that you can apply an access list. This may or may not be one of the first nuggets that you look at as you go through the entire CCIE series, but if you look at the ISDN nugget, we talk about applying access lists to control when that circuit is dialed. If you look at BGP, we talk about using the access list to filter certain routes from getting to certain neighbors and saying what routes are being allowed to come through. If you get into network address translation or NAT, you use an access list to define what addresses are going to be translated and filtered through your router. Access lists can be applied to a plethora of tasks that you do on your Cisco router. However, here are the facts that you'll need to know about access lists. Number one is that by default, there is an implicit deny at the end of every access list. Now, this one has haunted many people. They forget about it, and they'll create an access list, and they say, well, I want to deny this person, and that person, then apply that access list to an interface. Well, if you create an access list with nothing but denies, then what are you doing? You're denying everybody, because if you don't explicitly permit somebody, once you reach the bottom of the access list, they're going to be denied anyway. The bummer thing about the access list is that it doesn't show up in any show commands. When you do a show IP access list, you won't see that implicit deny. Some administrators that I know actually type in an implicit deny, or not really implicit, a stated deny at the bottom of the access list, just so they can see it and remember when they do a show command. So by default, remember, if you don't allow access, they will be denied. Number two is that it is read from top to bottom, and it stops reading when a match is found. So you might have an access list that is a list of 5 statements. The top one says permit 192.168. The second one says permit 172.16, and so on. You go down this list. When a packet comes through, the router pulls out its access list, kind of like a scroll, and unrolls it one line at a time. It says, are you 192.168 dot something? No? Okay, let's look at the next line. Are you 192 or 172.16? No? Okay, let's look at the next line. So the larger your access lists are, the more overhead that they cause. It's also a good practice to make sure you put the most commonly matched statements at the top of the list if at all possible. So that way the router doesn't have to read through the whole list just to find the match statement at the very end of the list. From there, we see that new lines are added to the end of a list. So when you're editing a standard or extended access list, a numbered standard or extended list, we'll get into the named ones in a moment, every line that you add will be tacked on to the end. And by default, if you use a standard or extended numbered access list, you can't change that order. You can only add to the end, which means a lot of people use Notepad to modify their access list so they can reorder statements and then paste it into their router. Now, everything changes on that logic when we get into the named access list, and we'll talk about that a little later in this nugget. An undefined access list will permit all traffic. That's something that you may not know. If you go to an interface, say interface serial 0, and you decide to use an access list for access control, and you say, I want to apply access list 20, and you haven't done anything with access list 20, you haven't created it yet, it will be applied, but it will permit everything. However, this last one you may not have heard of. Deleting an access list after applying it to an interface causes a deny any for all traffic. Here's the nightmare picture I want to paint for you. You might have maybe just a router connected to a small business that's tied to the internet. And maybe you define an access list that's a little too restrictive. And you say, you know what? For now, I'm just going to delete the access list that I've applied to that interface so I can recreate it later. And you know, I just want to allow everybody access because some people are complaining they can't get to what they need on the internet. So you go to global config mode and you type in no access list followed by a number. Well, that access list has already been applied to whatever interface is connected to the internet. Once you remove it, there's a default deny any, even though the access list doesn't exist anymore. It kind of almost contradicts this statement up here because it was applied previously. If the access list does not exist anymore, that interface will deny all traffic, thus, yikes, cutting all access to the internet in that scenario. So with those facts under our belt, let's turn straight into the configuration using standard and extended access lists. Now I know this may be review for some of you, but you'll probably pick up a few key tips through here that you might not have known, especially when we get into how to test this, especially in the CCI lab environment where we don't have real hosts out here that we can use. Now standard access lists deny or permit based solely on the source address. It would be like me saying, I do not want telemarketers to call my home. I'm denying them based solely on who they are. In the same sense, I could say, I want to block or permit 150.100 to enter my network based solely on who they are. Now, the standard doesn't give me the flexibility to say what they can access, what protocols they can use. That's the job of the extended access list. Now, it does cost a little more router overhead to use these, but they allow you to say you are permitted or denied based on who you are, where you're going, and what protocol you're using to get there. You can even get as specific as using port numbers in that. So here's our topology that we'll be using through this access list nugget. I have 4 routers right here with 5 different networks. And what I want to do first off is create a standard access list. We'll start right at the beginning. And I want to deny 150.100 from being able to reach this subnet over here that has my server. Now, the first thing that we're going to have to do is create the access list, which is important. But I would say 60% of the game is where you put that access list. Here's the idea. The standard access list says you are either permitted or denied based on who you are. So if I created that standard access list and put it right here on router 1, maybe outbound on this serial interface, and I said deny 150.100, what would they be denied from? Well, everything. I may as well just disconnect the cable right here connecting router 1 to the cloud, because as soon as they reach this internet or the serial interface, it will say you are denied. I need to create this access list and place it on router 4, either inbound on this serial interface or outbound on that Ethernet interface. So let's go ahead and bring up the configuration prompt, and I'm sitting on router 1, and I first off want to do a ping to make sure I prove that I can reach the 172.20.7 network over there with the server on it. Now I'm going to do a show IP interface brief. I'm emulating as if I was connected to that cloud with a loopback interface, and I'm going to do an extended ping. Here's why, and this is tip of the day right here. I'm going to ping 172.200.7 or .20.7.100, which is this server sitting up here. Hit enter. Repeat count 5, that's fine. Datagram size, timeout. Extended commands I'm going to hit yes to, and this is where most people leave off. This will allow me to type in the source address or interface that I would like to use when I'm pinging that server. This is awesome because I do not have a host out here that I can ping from. As in the CCIE lab, many times you'll have routers connected to clouds that you can't access. You can't source a ping message from there, but you'll have to block access. This is how you'll be able to test it. I'll ping as if I am that loopback interface rather than ping directly out that serial IP. I'm going to give me some type of service. I can even test quality of service with this, but I'll just hit enter for the rest. And sure enough, there's quite a few. Sure enough, I can ping that server with the source IP address of 150.100.0.1. Good. Now let's jump over to router 4 and start creating the access list. Let me clear all this gibberish off the screen so we can start. I'm going to get into global configuration mode, and I'm going to type in access list followed by a question mark. Now, here are the two ranges we'll be interested in at this point: standard access list and extended access list. If I type a number from 1 to 99 here, I'll be creating a standard. 100 through 199, I'll be creating an extended. It doesn't matter what number you pick as long as it's in that range and not in use. So I'll pick one flat in the middle, number 50. And I will deny. That's the first thing I want to do. I want to deny 150.100. So I'll hit question mark, 150.100 from pinging that server. So it gives me some options here. I can deny any, I can use the any keyword, I can deny a specific host, or I can type in an address to match. I want to deny the entire subnet, not just a host. So I'll type in 150.100.0.0, the whole subnet, followed by my wildcard bits. And these are indeed wild. They're exactly the opposite of the subnet mask. Now, I've seen many books and many explanations get into the binary and how to calculate wildcard bits using binary math. And I'll tell you, it's really easy for me. What I do is I just take 255.255.255.255, all 255s, and subtract my original subnet mask to find my wildcard mask. So my subnet mask over here is 16. 255.255.0.0 in the decimal. So my wildcard mask will be, using that math, 0.0.255.255. Now I know you're thinking, well, Jeremy, you could just look at that and you could say, well, 16 bits, that's a class B subnet, so there's the opposite. Yeah, you can look at it, but right here I'm going to get a little more complex. You see a 30-bit subnet mask. I'm going to create a wildcard mask that matches that exactly, and that's when things just, I'm telling you, when you see that wildcard mask, it'll just feel wrong because it just looks outrageous. So that's where that math subtraction will come in handy. So at this point, I can log matches if I'm using a syslog server and I want to track it, but for now, I just want to deny. Now, if I went ahead and applied access list 50 to the interface, that would be detrimental because I would not only block this 150 subnet, but I would block everybody else because it says deny 150, and then at the bottom of this access list is the implicit deny. So I need to add one more line to it. Access list 50 permit, and I'm just going to use the keyword any. So when I do a show IP access list, I can see that I have my first statement, deny 150. The second one is permit any. Remember, it processes from the top down. As soon as it matches, it exits this access list. So they will be denied. Everybody else will be permitted. That's how you can overrule that implicit deny all. Now I just need to choose where to apply this. And I'm going to go ahead and apply it inbound on serial 0. Let me do a show IP interface because I know I've got a sub interface there. This is serial 0/0.1 that's connected to router 3. So I'm going to get in there, 00/0.1, and I'll do the command IP access group, followed by what access list number I'd like to apply, 50, and then the direction. Oh, so important, this direction. If I were to say out, that would track the packets that were leaving the router. Remember, this is from the point of the router's perspective, either coming into your router or out of your router. If I applied it out serial 0/0.1, it would filter traffic that was coming from this network, and it would deny anything with the source 150.100 coming this direction out serial 0/0.1. Now my question is, will there ever be 150.100 going out that interface? No. Only coming in as a source IP address will that come. So make sure you get that perspective right. If you just remember this is the direction from the router's perspective, you'll be okay. Otherwise, you start thinking, well, is inbound from where? Inbound from the internet? It kind of throws you off. So at that point, guys, we should be good. I'm going to go over to router 1, and I'm going to try that ping command again. Ping, extended ping, 172.20.7.100. I'm reaching that destination. I want to use my extended commands, and I'll say 150.100.0.1 is my source IP address. Go down through the commands, and voila, we are being denied. You see the U, which represents an ICMP unreachable message. The access list doesn't just drop the packets, it will respond with ICMP unreachables that lets you know you are being denied for a good reason. You can turn that feature off because this is actually an alert to hackers that there is an access list there. If you turn that feature off for the ICMP messages to go back, they will not know if it's truly unreachable, as in the network is down, or if it's being denied by an access list. Now, I pinged from this source, and I see that it's unreachable, but watch this. If I do a ping 172.20.7.100, look at that. I'm getting through. And the reason why is when I do just a normal ping message, where's it coming from? It's coming from this source IP address on the serial interface, 172.20.5.1, which is permitted to access this. So this is the true example of using a standard access list to block based on the source. But all the glory comes in when you start creating these extended IP access lists. And the reason I say that is because it never ceases to happen that you'll be typing in an extended access list statement, and they get so long that if somebody is looking over your shoulder, they'll look at you and go, wow, you rock at Cisco routers, because these look like huge lines of syntax, when really they're not that bad. Here's what I'd like to do. I'd like to block this host, 192.168.1.100, from using a web browser to access this cloud, 150.100, which could very well represent the internet. And we will be able to test that. And I'd also want to make sure that I don't halt any other access. I want this user to be able to use FTP, ping, whatever they want to use to access that cloud, just not web browsing. Here's how I'm going to test it. I have this Mozilla Firefox right here, Mozilla Firefox, and I'm going to type in 150.100.0.1, which is actually the interface of router 1 that is connected to this cloud. It's using HTTP to access that interface. So by blocking HTTP to that cloud, we shouldn't be able to access that HTTP interface any longer. But I'd still like to be able to do ping messages, and I can do that just from a straight command prompt on this PC. I'll do a show IP interface brief from a command prompt. How about ipconfig? ipconfig, and we have 1.100, that's the host we're looking at, and the default gateway is 1.2. So that would be this router right here. So that's where I need to start configuring my access list. So I'll pop up my Terra term, get into global config mode, and type in access list, followed by now the extended access list range, 150 through 199. Any number in that range will be considered valid to block those. I'll go ahead and use the one right in the middle, 150, just like we did with the standard. Now the first question it's going to ask is permit or deny. We'll talk about dynamic a little bit later in this nugget. So I'll say access list 150, and I want to deny to start off. I'm going to block that web access. Now from here it's going to ask me a different question than the standard access list. It's going to say, what protocol do you want to deny? If I wanted to block the whole TCP/IP protocol suite, there's my keyword. IP will do it. But I'm not interested in that. I want to block HTTP. So that is a TCP-based protocol, TCP port 80, right? I would also recommend that you become somewhat familiar with the common applications that you have and their port numbers and what protocols they use when you're preparing for the CCIE lab exam. So I'll use TCP. That's what I want to do, and I want to say a single source address. That source address is 192.168.1.100. That's me. And the nice thing is we can use that host keyword instead of typing in the source address followed by a wildcard mask of all zeros. I'll type in host 192.168.1.100. Now this is where you got to be careful. Watch out here. It says, okay, now what port number? Which I typically will use this EQ to say match port packets on a given port number. But as of right now, we're referring to the source IP address and the source port number. Anytime you open an application that accesses the network, for instance, I just opened Firefox right here, you can access the web browser interface with that. It generated its own source port. So I've got 192.168.1.100, and the source port would probably be something like, well, let's find out. Let me refresh that page so I can reinitiate that connection. I'll bring up a command prompt and type in netstat. The source port that it's using for the web interface, looks like it closed down too fast, but over here are all the source port numbers. You see TCP 1260, 1261, 1111, 1115. These are all source port numbers that it's opening up for all the source connections that it has. So when I open that Firefox, access the web page, if it were still loading, it would show up in that netstat command. I would probably see something like source port 2140. What those are for is so when this network sends back to you, it can put the information into the right application. It knows to send it to Firefox and not put it in my telnet session. So this is going from a source port of 2140 out to a destination port of what? 80. Right? HTTP. That's how it knows on the server side what server it should be sending to. So when it asks me in my tera term, do you want to deny on a certain source port? The answer is no, I don't want to, because I don't know what that source port number is going to be. So I'm just going to leave the port blank. I'm going to go straight to the destination address. That'll be 150.100.0.0 followed by a wildcard mask of 0.0.255.255, just like we did with the standard access list. Now I can go ahead and say I want to deny destination ports either equal to, I can single out a specific destination port. I could say any destination port less than or greater than a certain number. I can say a range of destination ports, which is really handy when you're trying to block those P2P applications, peer-to-peer applications for file sharing, or things like Kazaa, things that use different ranges of port numbers and dynamically change on you. But for this case, we'll go ahead and use EQ. And I'm going to say equal to, and oh, I love this context-sensitive help, because it gives you all the major applications, the common applications, not all of them, but the common ones that people allow and deny. But always notice you can type in any port number that you want to allow or deny, or you can choose one of these nice keywords in the list. In this case, HTTP or www is a common enough application that it shows up in the list. From there, I can pretty much hit enter to say I'm done. There's some other commands you can use if you're dealing with quality of service. You can specify different port numbers, log the entry if you're using a syslog server, but that's my one statement. See? It looks impressive, doesn't it? People are going to look over your shoulder and go, wow, you know what you're doing. So from there, I've denied that host, but now I want to permit everybody else. I can't forget that permit statement, or else I'll deny followed by an implicit deny and thus cut all access. So I'll say access list 150 permit followed by, well, I'm not going to say a specific protocol. I'm going to say the entire TCP/IP protocol suite for any source to any destination, and I'm not going to type in any more than that because that allows everything. That's my permit all. So I'll do a show IP access list. And there's my extended access list 150. It's working fine and dandy, but I haven't applied it to an interface, so it's not catching any traffic. So I need to go into, let me do a show interface brief so I can see what I've got. And I will go, I'm on router 2 here, So I will go under, let's do Ethernet 0. See, this is the beauty of extended access lists, is you want to apply them as close to the source as possible, because now that client doesn't have to cross the rest of the network to find out it's denied. For example, when we had the ping traffic blocked from 150.100, it had to go through the WAN link, across the LAN, back up through the WAN link, all the way to router 4 before it find out, oh, by the way, you're denied. Then the ICMP unreachable would have to go all the way back out. See, with extended, we could have put that access list right up here at router 1, so as soon as it tried to access that subnet, since we can put the destination, it will be denied without having to cross the whole network. Kind of a nice feature of extended access lists. So, in this case, I'm going to go on router 2, and I'm going to stick that right on the Ethernet 0 interface. I'll do interface E0, IP access group, and it will be 150 in the inbound direction, because we have hosts coming into router 2 on this interface rather than going out of the Ethernet 0 interface. So at this point, my thought is it should be working, but that's just my thought. Let's test it. I'm going to bring up, first off, the Firefox. Let me go back to a blank page, and I'll type in 150.100.0.1, hit enter. Ooh, look at that. Never have I felt so good about a failed connection attempt. Connecting to 150, it's kind of hung there, and it's going to hang there for a while until all the messages come back and finally it realizes that it can't access that. But did we block all access or just web traffic? Well, we can do that. We can test that a couple of ways. I'm going to bring up that command prompt again and clear all that off of there. And first off, I want to do a ping 150.100.0.1, which is this interface over here. And sure enough, it looks like we're getting there, and I'll even try a telnet. I don't think I have a password set, so it'll probably reject me. Yep, password required but none set. But the point is, the telnet was able to get through. Otherwise, it would have just hung there on the telnet. So my other protocols are getting through. However, I am blocking. Let me just do a show IP access list. I am blocking web traffic, and you can see that my Firefox browser, I love this feature of access lists. My Firefox browser tried 6 times, 6 different attempts to access that web page as it started failing. By now, I'm sure it's popped up and has put a host not found in just timed out. Put a host not found in there because it wasn't able to get through. The permit IP any had 44 matches. That's 44 separate packets that were permitted to go through from the point that I applied that access list. So that's the foundation, standard and extended access lists. Now let me show you something that rocked my world. About a year ago, I was doing my standard access list using the the standard ones that I just showed you, the numbered access list. And then somebody came along and said, "Why are you doing it that way? Haven't you started using the named access lists?" And I said, "Yeah, the named access lists, they're kind of nice. It puts a name on it. It allows you to remove individual statements." And the fellow that I was working with said, "No, Jeremy, you haven't realized they've added some functionality to the named access list." And I'll tell you what, after he showed me what I'm about to show you, I will never go back to using the normal standard and extended numbered access lists. Here's why. I'm going to jump on router 1 and get into global configuration mode. Now, access list is created using the access list followed by a number command, and that's one way to do an access list. It's been around since Cisco came about. So to create a named access list, you type in IP access list instead to focus on the IP protocol. Now it gives you the option, again, of standard and extended. There's no number. You type in exactly what type of access list you would like to use. Let's use extended because we were just working with that. So I'll type in extended, and you can type in one of the expanded ranges if you want to stick with a number, but here, I'm telling you, you get used to using names after a while, because then you can just look at the access list and go, "Oh yeah, that's my access list to block internet traffic." Know how I know? Because it's named block internet traffic. You can name it whatever you'd like. It is case sensitive, so watch out. I'll just put demo as my name. Now it takes me into this NACL, named access control configuration mode. So from this NACL configuration mode, I can put in my permit and my deny statements. It's just like creating an access list, but watch this. Once you see this, you'll see why I'm so excited about this. I'll say, router 1, I'll permit 150.100.0.0. Oh, I forgot to type the protocol. Permit IP 150.100.0.0 wildcard mask. Pretty much the same style of commands. I'll put any destination. So I'm permitting that. I'll put deny. Maybe there's one host out there. Deny 150.100. Well, actually, that won't work because I put the big broad permit statements first. Let me just do another permit. I just want you to get an idea. Any source, any destination. Just a few commands to add to this, and I'll do a deny. Oh, this will be great. I'm planning this out as I go, and I just thought of a great idea. 150.100. We'll say 1.50. Maybe there's a host out there. And I'll use a wildcard mask of all zeros to say that specific host. Maybe there's a host out there that has this IP address, 150.100.1.50, that is a hacker, and I've logged them. I can see that they're always coming in from that IP. I want to deny that IP address. Well, what's the problem here? Well, the problem is I've typed that in after, well, two major commands, permit IP any, and permit 150.100.0.0. So if that host comes in, it'll match this statement first, and even if I were to remove that statement, it would match this one second. So in the old days, or in the legacy standard and extended access list of using numbers, I would have to delete the access list and start over. But let me show you this. I'm going to type in show IP access list. And you see right here, IP access list demo is the name that I've typed in. We see all of my permit and deny statements, but look at this. Check that out. 10, 20, and 30. You know what those are? Sequence numbers. They're generated automatically. I can change them to be whatever I want. I could have typed in the sequence number when I first typed it in, but I think it wouldn't have the impact that it will as I show you this. I'm going to go back in. I'm going to type in IP access list extended. Demo is the name. So I'm going back into that demo access list, and here's what I'm going to do. I'm going to type in no followed by this statement. No sequence number 30, deny IP host, etc., etc. I've removed that from the access list. First off, that was something you couldn't do with the standard number access list, so very cool feature right there. But let me show you world-changing, life-rocking feature right here. I can type in a sequence number to start it off. So I will say, I'll do this. I'll just paste, I highlighted and copied that. I will paste in my old command right there, but I will go to the beginning of the line and put 5. I think you have an idea of what I'm doing here. Exit back out, show IP access list, and what did I do? I fixed it. I put this entry before sequence number 10 and before sequence number 20. In the old days, that was only a dream. We had to blow away the whole access list and start over anytime we got things out of order. Now with these sequence numbers that they've added to named access lists, you can organize them and reorganize them, which is the key, in any flavor, in any direction that you would like to. So that's why when I hit the objective slide, in the beginning of this nugget, I said named access list. Would you ever use anything else? Well, in my opinion, not anymore. For any router that supports named access lists, which is, I think, iOS 12.2 and later, where they've added all this functionality, I would never use a numbered access list to do anything because the names are so much more intuitive. Now let's look at one of the most confusing access list types that I think I've ever encountered. It's the dynamic access list, also known as a lock and key style of security by Cisco. So if you ever want a huge configuration example, definitely search for lock and key on Cisco's website. This security method used to be very popular back in the day. Before IP spoofing was a major hacking type. IP spoofing can overcome this type of security. And once I show it to you, I think you'll understand why. Essentially, let's take this network example that we're looking at right here. We'll say that router 3 protects this top secret ninja part of your network behind it, where we have some private servers and so on that only certain people should have access to. Well, what we can do is enable dynamic access lists, which essentially cuts off all access at router 3. We'll say on this Ethernet interface. Now, what you can do is enable telnet access to router 3. So if a user needs access to this network behind here, we'll say 192.168.1.100, they can telnet to router 3 and authenticate with a username and password that you've given them. Once they authenticate, router 3 can open access either for just that one host or this entire subnet to go through and reach that server and these networks behind it for a certain amount of time. And you can configure either an idle timeout to say once they're idle for this amount of time, or an absolute timeout saying this amount of time is the absolute limit, no more time than this will be granted per session. Or you can combine both of those, which is what most people do, to say this idle timeout and this absolute timeout will ensure that somebody doesn't have a session on there that needs to be cut off early. The reason this is the most confusing type is just all in the configuration. In my opinion, it's kind of a not very intuitive configuration. Let me show it to you. I'm going to pop up TerraTerm, and I'm hopped on router 3 right up here. I'll do a show IP interface brief just to familiarize ourselves with what this looks like. And the first thing that I'm going to do is I'm going to create the dynamic access list. Get into global config mode, and I'll type in access lists. I'll use a numbered access list. It's going to be extended. So I'll just start with the first one, 101, and I'll permit TCP from any host to the host 192.168.1.3. Now who is that? That's me. So I'm permitting access from any source on any port number to the host 192.168.1.3 equal to telnet. So I put my first line is going to be the only real permit statement that says I'm only going to permit telnet traffic to this destination IP address. So that will allow people to telnet in so they can authenticate. The second statement that I'll type in there will be access list 101, and this is where it changes a little bit. I'm going to type in dynamic. Dynamic. And now I get to name it. So I'll just call it, again, demo. This will be the name of this dynamic access list. And from there, I get to type in, this will be my absolute timeout. This timeout right here. And I can choose whether to type that in or not. I will go ahead and say timeout, and we'll say 120. This is in seconds. Now, it doesn't tell you that, but this is the maximum time to live in seconds. So 120 seconds will be my absolute timeout. So if I have a session going over 2 minutes, even if they're not idle, I'm going to cut them off. So from there, I'm going to say what is permitted. And in this case, I'm going to say permit, and I could get specific and type in specific protocols, but I'll say IP any. That says dynamically what will be permitted to access that server. In this case, once a user authenticates, I want to allow full access to this subnet behind here. Enter. So that's the second line of my access list. Now I'm going to go under interface Ethernet 0, and I believe it's /0, yep. Ethernet 0/0, and I'm going to type in IP access group 101 inbound. So now I've applied that access list, which currently only allows telnet access, because this is a dynamic entry, to that interface. Okay so far? Me too. That's the logical part of this. This is where it gets a little convoluted. The first thing, oh, and notice this. You got to watch out for this. I just cut off EIGRP traffic because I denied everything except telnet. So you have to make sure you allow specific provisions in your initial access list to allow your routing protocols to work correctly and so on, because I've just cut router 3 off from the rest of the network by applying that access list. So I'm going to jump out of here, get back to privilege mode, and actually I'll get straight into global config, and I'm going to create that user account. I'll do username followed by the username, let's just say access will be the username that I want people to authenticate with, followed by the password, and I'll say the password is access, just so I don't forget it. Not a very secure method, but I've just created a user account on my router. Now I'm going to go under the line VTY. 0 space, and I've got enterprise iOS, so I've got quite a few telnet ports available on here. 0 through 181, and I'll type in a few commands. Login local to say look at the local database, as in reference that user account that I just created. That's the local database of this router. And then here's the confusing command, auto command. Something that you may remember if you've ever configured modem access to your router. This auto command syntax allows the router to execute a command as soon as you authenticate to one of the ports. Now in this case, I'm going to type in auto command, and this is one that you have to enable. It says the appropriate exec command. You type in access enable, and the problem is that after this, the context-sensitive help kind of goes away. It's like, yeah, type in the command to execute. So you have to remember this one from memory to configure this. This is why I commonly use online documentation to help me out when I configure lock and key. Auto command access enable followed by the idle timeout. Timeout, and you can see no context-sensitive help. This is in minutes to make it even more confusing. I'll say an idle timeout of 1 minute. So my absolute timeout is 120 seconds or 2 minutes, which automatically cuts access. But if they're idle for 1 minute, I'm going to cut them off early. Now, if I type in this command, the auto command access enable timeout 1, that will pretty much allow them, it executes that dynamic access list as soon as they authenticate to the router and adds that entry to my access list table to allow access through. But just typing this command will allow the entire subnet, 192.168.1.0 or whatever subnet authenticates, the entire subnet will be able to access this. If I want to restrict it to the host, I type in access enable followed by host timeout 1. That way, whichever host, individual IP address authenticates, only that host, not their whole subnet, will be allowed through. And that's usually the more secure way of doing it. That command has to be in there, and that is from the line v2y0. Now, do you see why I say this is the most confusing access list type? It's because that command to me is so counterintuitive. It's just not something I would remember off the top of my hand. Thank goodness for online documentation. So from there, at that point, I should be able to jump out and test this access list. So I'm going to jump on this computer, 192.168.1.100, and try this out. I'll first bring up a command prompt and type in ipconfig. Just so you can see what I'm looking at here, I went ahead and modified this computer from the extended access list. Same IP address, but it's now pointing to a different default gateway. It's pointing to .3 here instead of .2. The reason I could have pointed it to .2 and left it fine, but remember when I added that access list, I lost my EIGRP connectivity. So router 2 doesn't really know about any of these networks anymore. I'd have to modify that access list I created for this dynamic access list demonstration to allow EIGRP in order for the full communication to work. And in my mind, it was easier to just change my default gateway. So I'm going to do a ping to 192.168.1.3. You notice that my computer cannot reach its default gateway, and it's coming back now. It took a second, but it came back with destination net unreachable because ICMP unreachable messages are coming back. I'm being blocked by the access list because you remember the access list only allows telnet from this subnet. I'll also, just for sake of it, I'll ping 172.20.7.100. That server back there, 20.7.100. And you notice, again, destination net unreachable, I'm being denied by an access list. Now, this is the coolest part of the demonstration, so hold your breath. I'm going to telnet to 192.168.1.3. Enter. Comes up, says user access verification. I'll type in access as my username, and the password is access as well as that user account I just created. You see what happened? It hung up on me. Connection to host lost, but wait, watch this. I'll hit the up arrow, ping, aha, it's begun to work. I'll ping the server behind there. Aha, it's begun to work as well. As a matter of fact, watch this. I'm going to bring up the Cisco prompt, router 3. I'll do a show IP access list. And right there I see my access list I've created, dynamic demo permit IP any, and look at this. Dynamically, it squeezed in permit this host because I included the host keyword in the auto command access enable I typed just a moment ago. And look at that. Time left is 53 seconds. Now, if I kept pinging, now that's the absolute time, or I'm sorry, the idle timeout time left because it was 1 minute for an idle timeout and 2 minutes for an absolute timeout. So if I kept pinging, that time left would keep resetting itself back up to 60 seconds because I set the idle timeout to be 60 seconds. Now, if I kept pinging, eventually, I'm not going to do it, but eventually at 2 minutes, it would cut me off. This would be removed from the access list table. It would be removed from the show command. And what would happen is I'd have to re-authenticate from this device, this PC, in order to be allowed access again. Now can you see why IP spoofing kind of outdoes this access attempt? Because once this person has authenticated, which I used Telnet to authenticate, not SSH, which is the encrypted version of Telnet. So somebody could have been monitoring that, doing some packet sniffing. They see the username and password. They see which IP address I used to authenticate. They can use an IP packet spoofer now to get through. That's why this method of security needs to be combined with something like encryption to make sure that, number one, I can't read that authentication going across in clear text. And number two, only this device have like a client server encryption key method installed on that device. So only that device, not a spoofed device, would be allowed through to get through the encryption after the lock and key has opened the firewall. So I've saved the best for last, at least in my opinion. I love configuring time-based access lists. Now, I don't get to do it very often because most people say flat, this person is denied or this person's allowed or that subnet is denied or that subnet's allowed all the time. But using a time-based access list, you can apply a time range to any access list entry that you want to say, during this time, during this day of the week, during whatever parameters you'd like to set on a time basis, this entry is valid. So you can apply this to dialer lists when you can say, I want to restrict the ISDN from dialing during these times of days, or you can apply it to traffic types to say, I only want web access to be available during lunch hours or something like that. Well, however you'd like to apply this, pick a scenario, and time-based access lists can usually fill that in, at least for any time-based control that you would like. Here's how you do it, and it's very, very simple to configure. The first thing you need to do is create a time range, and that's going to be done from global configuration mode. You just type in time range followed by a name for the time range. So I'll say HTTP time. In there, you will be able to define a time range, and you have two real keywords that you'll use: absolute or periodic. Here's the key. Absolute, you can only type in a single time range. You can only use that command once. So if you typed in absolute followed by the start, that is going to be the absolute starting time, the starting date, the starting range of when it is allowed. And that is the only command that you can type in. Now, periodic, on the other hand, you can have multiple of these commands typed in. So you can say periodic, I'll say on Monday, Monday through, we'll say Friday. I don't know why my brain didn't quite work there. From 8 a.m., 8 o'clock in the a.m. to, and I'll put the ending time. And remember, military time for us Americans, that's sometimes hard to grasp because we rarely use it. Let's see, 16 minus 12 would be 4 p.m. So I'll say 1700 hours. So pretty much a work day. 8 a.m. to 5 p.m. Monday through Friday. I've defined my first periodic range. Now, if I wanted to do periodic again, I could say maybe on Sunday from 1 to 4 p.m. or whatever range I want to type in there. I can type multiple periodic commands. So that is how you create the time range. Now that it's created, and I got to remember that name, it is HTTP time _time. Any access list entry I want to apply that to, for instance, I'll say access list 105. We'll say permit TCP from any source to any destination on port 80. Now I can type in time range HTTP time. See that? That's all I need to do to tack on a time range to any access list entry. At that point, when I hit enter, that permit statement is only valid from the time range that I defined in here, Monday through Friday, 8 a.m. to 5 p.m. So I've essentially said web access is only allowed during business hours, which seems a little counterintuitive, but you get the idea. You can tweak that time range to be whatever time you want. Just make sure that, here's the other catch, I'll do a show clock. Make sure your clock doesn't look like this. In order for those time range to be accurate, you need to make sure you set the clock on your router to be accurate as well, or else you may end up having problems in the future. Just a note, when you're on the CCIE lab and you're doing a time-based access list, it may not tell you set your clock right, but you need to make sure you remember setting the time range is one part of it, but making sure that your clock is right is definitely another. See, now wasn't that better than a Caribbean cruise? I'm telling you, access lists rule. What did we hit in this chapter? Well, we started off, we came a long way in a short time. We started off with access lists, the foundations. What they're used for, they're not just access control. We talked about dialer applications, NAT application. They can be used for just about every major router function. From there, we hit the foundations, how to configure a standard and extended access list, and that kind of brings everybody up to the same page, and also talked about the facts about those access lists. If you apply an empty access list, what does that mean? If you remove an access list from an interface, what does that mean? That sort of thing. From there, we hit my favorite, named access lists, where you can now have sequence numbers allowing you to organize, and the key is reorganize access lists in any way, shape, or form that you want to. We then hit the lock and key, which is a little outdated by spoofing, but still a very secure method to lock down certain parts of the network, especially if you combine it with encryption. Then finally, we finished off with, it's simple, but it is powerful, a time-based access list, allowing us to define time ranges that the entries are valid on any access list that we want to apply a time range to. I hope this nugget has been informative for you, and I'd like to thank you for viewing.